Okay, in this problem we want to evaluate this triple integral, and we know instead of dv we can say dz, dy, dx. Our z would correspond to this, our y would correspond to this, and our x would correspond to this. I'm just gonna set it up like this. So triple integral, I will say it will be x parentheses y plus 2z. So this. And instead of dv, I'm just going to say dz, dy, dx. And if that's the case, dz would be correspond to this. And z is 0 lower bound, 2 upper bound. Y would correspond to 1 lower bound, 3 upper bound. And dx would correspond to 0 lower bound, 1 upper bound. So we will solve this. So let's do it. One thing we can do just to make our lives easier is somewhat split it. We can say the integral 0, 1. We can say x dx. So we're removing this, we're removing the x, and removing this integral. And we will multiply the double integral of 1, 3, 0, 2, and then just y plus 2z, and we would keep dz, dy. So we would get y plus 2z. Dz, dy. So now we will solve these two. So the integral of x would be x squared divided by 2, and we will plug in 0 for lower bound, 1 for the upper bound, times the integral of 1, 3, and what we're going to get for this will be, we'll take the integral in terms of z, so we would get zy plus, we have z, so 1 plus 1 is 2, divided by 2, cancel out this 2, and we would get z squared. In terms of dy, but our bound was 0, 2. 0, 2. So when we plug in 1, we get 1/2. 0 would be 0, times, now we're plugging in the 2. So we'll get the integral 1, 3. By plugging in 2 for z, we will get 2y plus 4 dy. And we can say 1/2 stays the same. Now we take the integral of this in terms of y. So 1 plus 1 is 2, divided by 2, so we get y squared plus 4y. And our bounds for y was 1, 3. So we're almost there. So now we'll simply plug in the values for y. So we can say 1/2, 3 squared is 9, plus 4 times 3 is 12, minus parentheses, we plug in 1, so we get 1 plus 4, close parentheses, close, and this would equal 1/2. 9 plus 12 is 21, minus 1 plus 4 is 5, minus 5. So 21 minus 5 is 16. 16 divided by 2 is 8. So equal 8. And this is our final answer. And that's all we need to do.